complete the solution part here. Yeah. Yeah. Actually, because here the absolute value, right? Yeah. So if first we keep the absolute value, yeah. So V equals x squared. Yeah. Next, we want to remove absolute value. Yeah. So plus, minus, two cases. Yeah. First, we keep that plus minus cases. Yeah, because we don't want to miss anything. Yeah. But we want to make it as simple as possible. Yeah. Here, because the two cases plus minus, not that clean, right? Yeah, not the best we want to have. Yeah. So for that reason, we want to ask ourselves, can we remove it, the sign part, only keep the positive version? Yeah. So here we want to consider the case that V equals, because why you can do this? Yeah. So we need to make sure this way is correct. Yeah. Remember, when we solve this equation, we want to find y1, y2, and two special solutions. Two special solutions, yeah, or two particular solutions you can call, yeah. But here, yeah, here I want to separate. Although they also satisfy the meaning of the two particular solutions, but because the situation we use is slightly different. Yeah. So in order to separate the different situation, because particular solution we use for the non-homogeneous case, right? Yeah, non-homogeneous case, we use that particular solution. Yeah. So here it's the homogeneous case. Yeah. Let's call these two special solutions, not general solutions. Yeah. So here, when we find the V or U, we only want to find a special solution. Yeah. So for that reason, the question, this version, is this one a solution of the equation? Yeah. One solution of the equation? If it is, then we just take it, right? Yeah. Yeah. So here we can verify it. Okay. Verify it. Yeah. Yeah. The result is yes. Yeah. I check it on the scratch paper. Yeah. Yeah. Although I can do it here, but it's not necessary, right? Yeah. Yeah. So we can take V prime. Yeah. Before we take the V prime, we can write in the x to the negative first minus x to the negative second. Okay? Yeah. So then you take derivative term by term. V prime equals negative 1 over x squared, right? Then positive 2 over x cubed. Okay? Yeah, and so on. Then you plug in, it's very simple. They'll cancel out. The first term, second term cancel out. Then it's 0. V So this positive version of the V satisfy the equation. Yeah. That equation. Okay? Yeah. So that means as a special solution, this V is good. Okay? All right? So then the next step, because V equals U prime, so U prime equals x minus 1 over x squared. Yeah, we'll write it separately. 1 over x minus 1 over x squared. Yeah. Then U equals integral these two terms. Yeah. Then natural log of absolute value of x plus 1 over x. Yeah. And we don't need that c part. Yeah. The reason is for this u function, we only need a special solution. We don't need a general solution. So we do not need to include the constant c part. Yeah. Then another thing is here you also see absolute value of x. The question, how do you handle this? How do you, is it possible to simplify it? The answer is no. Here you have to keep this absolute value of x inside natural log function. Yep. Do not simplify it. Yeah. Yeah. So then, after that, y2, we assume y2 equals ux. Then you use x minus multiply absolute value plus. Yeah. So then you have x equals, the final form, you have 1, right? Yeah. Yeah. But you still keep this absolute value here. Yeah. Yeah. It's okay. Not too bad. Yeah. Inside natural log. Yeah. Inside natural log. Yeah. All right. So you have y1, you have y2, then, yeah. So yeah, the general solution is c1y1 plus c2y2. General solution. Okay? So you complete the solution. Yeah. All right. Yeah. So that's the first one.